Hello, hello, and welcome to this second video on C++ programming. So the first thing we need is the compiler. So on uh, Arch Linux or Manjaro or Endeavor, you can run pacman -s gcc. Of course, you need sudo. So I have already installed it. I'm just showing you. On Debian, Ubuntu, or Mint, you can say sudo apt install gcc. On Red Hat, Fedora, you can say sudo dnf install gcc. And on OpenSUSE, you can say that sudo japper install gcc. If you're on Windows, you can have Visual Studio application. You can install this community edition and it will install the compiler and everything. Okay, so I'm not going to use Visual Studio. This is my Arch Linux on WSL on Windows. So we are going to use this. For editor, I will be using VS Code, and we need CC++ extension. So this extension you need CC++ extension pack, and you're good to go. So once we have that, I've created a small program. So this is the smallest possible C++ program. Your main is of type int. That is, it returns an integer and we are returning 0 from it. 0 indicates success. Positive or negative numbers you can return, but they will be failure. So how should you compile this? You use GCC, G++ instead of GCC. -all enable all warnings. -w error treat all warnings as errors. -std is equal to C++ 26. We are going to use the 26 version of C++ by standard, and you do -pedantic so that your code is standard compliant. Pedantic means ISO standard compliant, and then you give the file name, and it should be compiled immediately because there is nothing in the program as such, and we run this, there is no output. But if you say echo dollar question mark, it will tell you 0. Now you may say that 0 has come from somewhere, so we say return 18. So again, we need to compile, we run the program and we see it is 18. So certainly it was not fluke. Now, for C++, first thing which you are going to see is that you are not going to use printf and scanf. Instead, you are going to use cout and cin for input output. So first, you want to include iostream header file, and you use cout like this: std : cout. Std is the namespace. You will learn about namespaces later. You can say hello world. And you can either use \n or you can say in C++ style std : endl. This is the new line for us. It will send a new line and hello world will be printed and prompt will come on new line. Okay, let's compile this and run. So we have hello world. What happens if you don't give this std endl? I'll show you. Suppose we don't have this, then there will be a difference. They see after this hello world, this prompt came on new line after a line. But here, if std_endl is not there, then this hello world is here, and immediately after that we have the prompt. So std_endl sends a new line in the output. So far, so good for printing output. What if you want to take input? Suppose you want to read an integer n, then you say std : cin, and you say I. That's it. No %d, no %f, nothing like that. C++ cin knows that it is an integer and it will read accordingly. Okay, and then you can send it in the output. Cout, and you can say I, then say std : endl. If you don't want to type std colon colon all the time, you can use a shortcut which is not recommended. You can say using namespace std. But in general, it is not a good idea to do this namespace usage because function names might clash. At that time, you will be forced to qualify by the namespace name. But for us, small programs, it does not matter. And we will not use any other namespace other than std. Whoa, 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 whoa. You see the kind of problems we have? Okay. So this should be greater. You see, one mistake can cause so much error message. That is one problem C++ definitely has. Okay. We compiled and now we run this. So it will ask for an integer. What am I doing? Dot slash a dot out. So let's say my favorite number 7 and it prints 7. What if we want to take input of two numbers? Then you give ij and you simply do like this. And then you put j and then that. Okay. So again we compile, we say a dot out and we enter 7 and 10 and it prints 7 and 10. If you want to put a space, you can do so like this. And we put 10 and 20 and we get 10 and 20. Oh, we didn't compile or what? Because there is no space here. 10 and 20 and there is our output. Okay. Now, the first thing which we want to talk about is that you should know C very well. If you don't know C, I'm not going to cover all those things. So you must learn C from some book or maybe watch something on YouTube or anywhere, use AI, I don't know. You can watch my C video series. Well, the playlist is there. The audio quality is not up to the mark, but it is what it is. I was a noob when I was recording the videos. The first top thing I'm going to talk about C++ is object-oriented programming. And the base of object-oriented programming lies in something called class. So we can create a class like this. It is an empty class. Okay? And it has nothing, no members, nothing. If we want to create an object A, we can create like so. Okay? This is the constructor call of the class. So this is class name and class is the keyword. And we create an object small a of type A by calling the constructor. Let's say where did this constructor come from? So before C++11, the compiler would provide you with a constructor, a destructor, copy constructor, and assignment operator. After 11, it provides two additional things. It provides us a move constructor and it provides us with move assignment operator. Okay. So this constructor is provided by the compiler. And how about memory? Where does it go? So it will go to stack. And after the program ends, it will be automatically cleaned up. If you want to create a pointer on heap, you can say a star a is equal to new a. New keyword creates an object and puts it on heap. The same keyword is used by Java also. I believe JavaScript also uses a new operator. So new will put this on there. But if you allocate on heap, you must delete it yourself. It doesn't matter for our small programs, but in long running program, if you don't delete and this small p goes out of scope, then it will be the case of memory leak. Okay? And you don't want memory leak in long running programs. This is the raw pointer version of class A. So B is a raw pointer. Ideally, you don't want to use raw pointer. You want to use unique PTR, shared PTR, weak PTR, those kind of smart pointers you want to use. But I will not go in there right now. I want to focus on the class first. Okay. Now classes can have members. So by default, the members are private. So I can have an integer A. That means methods outside this class cannot access this integer A. So the question is, how do you uh, change the value of int A? So the typical technique is to put this in a public namespace. You put a constructor, okay? And the ideal way to do it is that you initialize, you call constructor with an argument, and then you use initializer list, okay? But we won't do an initializer list. We will say this dot A is equal to A. And here we will pass it, say 5, okay? So this is also a constructor. It is an overloaded constructor. So now your A is printed in the constructor. That is one way of doing this. Otherwise, if you don't want to initialize A in constructor, okay, ideally you should. What you can do is you can call a function something like set A. A setter function, you can say, and this will receive an argument int A, and you can say this dot A is equal to A. And you can have another function get underscore A. Let me set the type of this void, and this would be int. So you can simply return this dot A. Okay. These functions set A and get A receive the object on which they are invoked. And that object is received via a pointer called this pointer. Okay. So for example, we create the object here and we say A dot set A and we say 5 and then we say cout A dot get underscore A. So this should print our whatever value we use in set A. Okay, let's see this in action. Again, I made some mistake. Right? So it says endl or endl is there. Right. Just remember A, which is of type. If we simply set A. Let's see. Do we need this? Okay. You don't need this pointer. They know you can put the A and B as such. We'll come to this pointer a bit later. So we run this program now and we got our 5. The question is now, suppose we have a class, empty class, and I'm going to talk about something important here. We create an object of an empty class. So how much memory would it occupy? Okay. So let's see how much memory it occupies. I'm not sure if I can invoke it in object, but let's see. Should be able to. Yeah, so it tells you it occupies 1 byte. The question is, why this object A occupies 1 byte? The reason is, if A does not occupy any memory, there would be no way to distinguish this object A uniquely. You have to identify the object in a unique fashion. So you need to assign some memory to it. Now let's talk a bit about theory, okay? Because that is important. We have seen quite a bit of examples. Let's talk a bit about theory. The classes are the very basic on which object-oriented programming is established. Right? Now, what do you mean by object-oriented programming? So classes you create objects from classes and then you do something with that class object. So classes can be inherited, classes can be nested, there can be default arguments, there can be overloaded functions, there can be swing functions, there is inheritance. There are three different ways of doing inheritance. There is then virtual type of inheritance, which is actually we always use. Then we have composition. Then we have design patterns based on this. Then we have exception handling. Okay. Then we have virtual functions and polymorphism. So there is multiple inheritance also. And how do you resolve multiple inheritance? So a lot of stuff comes into object orientation when you talk about classes. So I don't want to overwhelm you. I just want to give you a picture. And then there are template classes, there are template functions which are used to write them the code. And then there is standard library. So let's go back to our code which we wrote earlier. Okay. So when you do set A, okay, and say A is equal to B, then this function knows this A. And when you do get A, it knows A again. It returns the value A. All right. So, but this is not the proper way of setting A. The proper way is that you pass it here. Okay. And here you say int A. This will initialize A with whatever value you pass. Note that this A inside bracket is different. This is the A of object. Let's call it A1 to disambiguate it. Okay. So now it is clear. This syntax will initialize A with whatever value you pass to the constructor. Note that if you have multiple variables, let's call it float F, then we can pass a float F also, float F1, and you can change the initializer list to F1. Okay? And we can have another function get underscore F and return. Now this call won't work. Okay, we need to give it an integer and a float. Okay, and we don't call set anymore, and we give a space, and we call a dot getf. So let's see this in action. Expected number with the other side. Where did I make the mistake? Let me see. Before return, get f. Okay. Note to match this, probably missing a comma or an operator before return. Oh, the parentheses are missing. Okay, there we go. And we run this and we get 5 and 3 here. Why we got 3 while we passed 3.14 when returning f is because the return type is float, int. You need to make it float to make it return integer. So we have 5 and 3.14. So we saw quite a few things today. We installed compilers. We saw how to do cout and cin. We saw how to create the class object, how to put it on heap, and how to create object and methods. So these methods can be private also and protected also. There are three different access specifier, public, private, and protected. In general, methods are public. Okay, not always, but most methods are public. They can be protected also and private also. And data members are usually private, and usually they are written with an underscore in before their names if they are private. So those are coding standards, but these can also be public. Okay, so if I make these public, let's say for example, then I can directly set this. Okay, now I can say a dot a is equal to 7 because this is public. Private ones you can't touch directly. You have to go through the methods. But public ones you can touch directly. A dot f is equal to 2.66. Okay. In general, the idea is that your methods, your members, data members should be private, and you supply methods by which program can interact with this data. So since you control what is inside the function, you know how to change the values of data members. Generally, you don't allow data members to be public unless there is a need, of course. So I think I'll stop this video here. And in the next video, we will talk about this pointer and other things and friend functions. Okay. And I hope that you have found this video useful and informative on C++ programming. So thanks a lot for watching the video, and I'll see you in the next one with more examples. Till then, happy programming.